Hello guys, welcome to the new playlist. Name is the Think Statistically. In this playlist, we're going to talk about the basic terminology about the statistics. We will going to cover all the concepts related to study the data science. If somebody is a beginner and who want to start the journey to study the data science, this is statistics playlist for them to revise the concept, to revise the basic terminology which will be used in the field of a data science. So for this presentation, to understand what is statistics and how statistics come in the picture, how it become the one of the most important key pillar to study the data science queries. So what is first question is, what is a statistic? So here if you see in the picture 1, it is a collection of a data, it is a collection of the information which will be in the second picture, it will be analyzing in the form of visualization, and in the third picture you can see how we can take the insights from the data which collected by the first person in the first picture. So what is the statistics? Statistics is the study of how to collect, analyze, visualize and do inference from the data. This is one of the simplest explanation about what is statistics. Then what can or cannot statistics do? We should know before study what is statistics, what are the application of statistics. We should know what we can do with the help of statistics and what we cannot do with the help of statistics. So what we can do, we can track the weather for the next month, for the next 6 days. That means we can do some forecasting, we can do some weather forecasting, we can do some temperature, this is what everything come in the weather. We can do the sales tracking, we can do some kind of a prediction with the help of a statistic. With the help of statistics, what we can do, it is not much more important compared to know what we cannot do with the help of statistics. One of the example I see, people say we can't predict the stock market. Yes, I am agree, it is a truth. But what statistics cannot do, that does not imply like we can't predict the stock. Yes, we can predict the stock, but maybe it is a 99.99% chances that what we predicted, it will be a wrong prediction. But statistics can do that thing. What statistics cannot do, I will try to give you an example with the help of this movie, that Bahubali. In Bahubali, why Bahubali movie is so much popular? So when you go and collect this data, some people may lie, some people not give the data, and some people will tell we lied due to the cut-up point, the Bahubali, that climax, and some people will like due to the Dev Sena, and some people like due to the some of the high fighting scenes in the movie. So why the Bahubali movie is so much popular, we cannot tell with the help of statistics, because we not have the right information of a data. Some people may like due to this reason, some people may like due to that reason. So that is one of the most important thing you should know. You can think what statistics cannot do, instead what statistics can do. Okay. Moving forward, what are the type of statistics necessary to know? So statistics is divided in two categories. One is the descriptive statistics and one is the inferential statistics. The descriptive statistics is what? It's summarizing the data. Suppose when there is a cricket match, the T20 match between the India and the Pakistan, the India makes the 15 run in the 6th over, and same 15 run again India make in the 15th of over. So it is what? It's summarizing the data. It is what? It have the information how it can be descriptively presenting in front of you. That's come in the descriptive statistics. But what come in the inferential statistics, and which is one of the most important, is that come is the population and the sample. So it is very hard in the previous time to know about some results regarding the whole population. So what a statistician do with from the whole population, it take the small sample, they study about the sample, they study in the different form of a sample, and they make a conclusion, and then they do the prediction for the population. That means they draw the conclusion based on the samples to the population. That what's come in the inferential statistics. But in the descriptive statistics, like what is the mean, how many time, how much hours a normal man is sleeping, what is the average, what is median, what is mode, what is the interquartile range, what is this thing, and most importantly we are going to discuss the descriptive statistics in this playlist especially. So it's very important to know what is the data. What data is nothing, it is a kind of information, and how the data is classified. So data is classified in two categories. One is the structured data and another is the unstructured data. So what is the structured data? The structured data, it is nothing, it's that the data which comes in the rows and the columns, and we can say the data which come in the matrix form or which can come in kind of a table form is a structured data. But can any video come in the table form? The answer is no. Can any image come in the form of the table form? The answer is no. So images, audio, voice, the IoT, these data are the unstructured data. And today's world we are working more towards the unstructured data. To work with unstructured data, the first step is that to convert in the structure format, and then we proceed our inference towards the unstructured data. So the text, images and the videos comes under the unstructured data. Okay, moving forward, how the structured data is classified. We have the data that is classified in two categories. One is the quantitative and another is the qualitative. One is the, now this qualitative is again classified in two categories. One is the continuous and one is the discrete, whereas the quantitative data is classified in the nominal and ordinal way. So continuous data is that, suppose we are measuring the height of a people, suppose we are calculating the weight of a people. So what is the height, what is the weight? This is the continuous scale. It can be measured on the scale, it can't be count, so that it's come under the continuous data form. Whereas suppose how many data, how many classes we have, the things which we can count, it's come under the discrete. Say the example of the binary classification, the outcome is the yes and no. That what I can count it yes and no. That means it come in the discrete way. But more interested is the nominal and the ordinal data. So what is the nominal data? Nominal data is the naming variable, such as I have the red hair, I have the blue hair. Say we have the collection of hair, so red hair, blue hair, black hair, then gray hair. So naming variables such as hair color. But what is the ordinal data? When you order a food from the Zomato and when it comes for the reviews, what reviews you guys give, that's come under the ordinal data. If you give the 5-star, it go excellent delivery from the Zomato or Swiggy bar. So up to this time, what we have covered what is the statistics, what is the data, and how the data is classified. But where the location of your data, it is one of the most important concept. To estimate the location of a data, we have the few terminology. Let's go firstly to on them to understand what are the technology. So how can we know where the data is located? So to know where the data is located, we have the term known as the central tendency. In the central tendency, we have the mean, median and the mode. So what is the mean, median and the mode? That's what we're going to discuss under the estimate of the location of a data. So mean is nothing, it is just calculating the sum of all the observation divided by the total number of the observation is the mean what you get. So median is what? Median is the middle value of your sorting data. That is, if you arrange your data in the ascending way, then what is the middle value come, that is a median for your data. But suppose the number of observation is odd, then the median is n plus 1 by 2, whereas if it is an even, then you have to be calculate n by 2, then another value n by 2 plus 1, and then you have to be average of two values to get the median. This is the concept. But how you choose that you have to be apply the mean or median? This is the interesting question. to know. So mean uses all the observation for the calculation. That is, mean is sensitive to outlier. What is outlier? It will be some strange value in your data set, but mean will consider that value also to calculate the one metric for you. But is the median will do that one? No, because median is always the middle value. Let us suppose you are living in some society where say you are living at one street where the 11 houses are there. Say the 11th house is the one of the richest house in your street. Suppose you want to calculate the average income, the income of your street, of adding all the income of your of all the houses in your street. Suppose if you calculate the mean, then the 11th house person with the richest person will definitely affect your mean value. But if you calculate in case of a median, then you are a safe side, because median is always give the middle value. That what I try to show here with the help of three picture, that is known as a skewness, and later we're going to talk about. Say if you see in the positive skew, the mean is greater than median, but in the case of a negative skew, the median is greater than mean. That means median is not changing the position, whereas mean changing the position in the positive skewness and the negative skewness. That means mean is more sensitive to the outlier. So when we have a choice to choose the mean and median, we mostly go with the value of a median metric. Oh, third term come, what is a mode? Mode is the highest value in the data set. Let us suppose you are staying in the Delhi, say, and you want to take the bus to go to the Shivaji Stadium, and you know the 620 bus number will come always to this bus stand to take us for the Shivaji Stadium. So what is the frequency in a day? So that is a mode. So mode is the highest value in your data set. So most frequent value in the data is the mode. Okay, as I told you, what is an outlier? It is a strange value in your data set. Say in this example also, you can see all the peoples are moving this side, running this side, but this person is calling to somebody in that side. So to see this data set, I can say this person is the outlier in this data set. Okay, skewness, as I told you, skewness, we have the three shape of a data. One is a symmetrical distribution where all the mean, median, mode is equal. We have the negative skew and we have the positive skew. In the positive skew, the mean is greater than median, and in the negative skew, the mean is lesser than median. That's why we always choose the median as a matrix in place of a mean, because mean is a more sensitive to the outlier. Moving forward, after knowing the estimate, after knowing our location of the data, it is much more important to know how your data is spread, how is your data is varying between the two pillars in your data set. That means we are going to know how much it is stretching in this section. So that is a name known as the measure of spread. So measure of spread is the deviation. So deviation between the predicted value and the true value, what is the difference, is known as the deviation. So difference between the observed value and the estimate of a location is known as the deviation. Okay. Moving forward, the variance is one of the most important. So I write the few steps how to calculate the variance. Variance is nothing, how much your data is varying from the mean is known as the variance. So to calculate the variance, first you need to subtract the mean from the each data point. Let us suppose you have the 1 2 3 4 5, you have the mean, so you have to be subtract the mean from all the 5 points. Then you have to be square the each distance. You have the new column, now you square this column, then add them together and divide it by n minus 1 to get the variance. If you get the higher the variance, means more spread of your data, and be sure and be remember that unit of your variance is the squared, because variance is the squared. We are squaring the distance. Now one of the question can come here, why we are dividing it by n minus 1 instead of n. This is something related to the biased and the unbiased estimator. We always interested to make our our analysis unbiased in place of the bias. So when we study about the inferential statistics, I will definitely try to give this answer, but to make sure our variance is unbiased, so that we divide it with help with the n minus 1 in place of n. If we divide it with n, then we can guess the bias estimator. How? That question answer we will give later in our section. Now, one of the most important and one of the most disadvantages of the variance is that the unit of the variance is the square. That means whatever you calculate, you will get the square term. Suppose you get the number 16. So 16.5, it is not much more interpretable compared to the 4. So we want something without scale. That is a problem of standardization and the normalization in the data science, and that's what we come here in the picture of the standard deviation. Standard deviation is the square root of the variance, and one of the biggest advantages is that it kills the unit. So free from the unit scale is the standard deviation. That's why the reason we use mostly standard deviation compared to the variance, because variance have a unit and we want in data science the unit free scale. Okay, so another term come the mean absolute deviation. So the mean of the absolute values of the deviation from the mean. That means you have to be calculate the mean, you have to be subtract the values from its mean, and then you have to be taking the absolute. That means you have to be take the mode, generally if I tell. So the mean absolute deviation. Now the question come here, you will go with the standard deviation, that outlier will affect more to the standard deviation, or outlier will affect to the more to the mean absolute deviation. So the answer is outlier will affect to the both and equal manner. So we should go with the help of the median absolute deviation. The last section of this presentation is about the percentiles. So percentile is nothing. So we have the, suppose what is the meaning of the 90th percentile. So 90th percentile here, first we have to be sort the data, then we have to be start with the smallest data and proceed up to the 90% of the largest data. So some values will come from the 90% of this side and some values will come from this side. So 90 percentile is nothing. It is the same as the quintile. In terms of the quintile, it is a 0.9 quintile. So 0.9 quintile is equal to the 90th percentile. Interquartile range. Interquartile range is the difference between the Q1 and the Q3. To if we get this difference, then we get the interquartile range. Interquartile range is one of the most important concept to avoid the outliers in the data set. Where if we do together between the Q3 quartile from the Q1 quartile, then we get the interquartile range. Q3 means 75% of data and Q1 means 25% of our data, and this is the this interquartile range application we will study when we study the normal distribution function. Okay, now you know where is your data, you know the estimate of the location, how you can locate your data with the help of central tendency, how much your data is varying, you can know with the help of measure of spread. It is much more important to know what is the kind of a distribution of your data, because every data have some shape. We have to be know what is the shape of a data. So that one we will gonna explore in the next video, and we will see some kind of data distribution exploration in terms of the data distribution. So I hope you like this video. If you like this video and if your concept revise there, if I'm a little bit fast, then let me know in the comment section, and if you have any query, then please let me know in the comment section so I can give an answer. I hope you like this video. If you like this video, then please like, share and subscribe to my YouTube channel for more videos. Thanks and bye bye.